Righto, year 11. I'm going to go through this differentiation from first principles because a couple of people are having some problems with it. And I'm just going to do some of the questions from question 11. I'm not going to do all of them. I'm going to do some of them. Now, we already did 11A in class. I'm going to do 11B and 11D and leave 11C for you. So, here we go. Now, remember, the whole point of what we're trying to do here is we're trying to find the gradient of the tangent at any point. And differentiation from first principles uses this. We proved this earlier for any function. The gradient of the tangent, or indeed the gradient function, equals the limit of the secant that we could get. So the limit as h approaches 0 of f of x plus h minus f of x over h. All right, because what we're doing is we're subtracting the y values on the top line and we're subtracting the x values. And remember, the two y values we have are f of x plus a little bit, that's a y value, and x plus a little bit, that's the x value. That's the point. And the other point is x and f of x, whatever we do to x. Now, when we subtract the x values, when we subtract these two, x plus h and x, which is on the bottom line, we're left with h. And on the top, we've got f of x plus h minus f of x. Can you see it? We're subtracting these two, and there they are on the top. And to find the gradient of the tangent, we're going to find the limit as h gets very, very small. So that's what we're doing. So now let's all apply it. And that's a general, because we used algebra to prove that earlier on, that will work for any function. So if we look down here at 11b, we have the function x squared plus 5x. Well, that's okay. That's our function, which is our y value, but we need f of x plus h. Everywhere there is an x, I'm going to put x plus h, and I'm going to put it in brackets because I have to do everything to the x plus h. So here we have x plus h all squared plus 5x plus h, which is, well, I'll just expand this first bit, and that becomes x squared plus 2xh plus h squared. And now I'll expand this bit, and that becomes 5x plus 5h. And now I'm all set to go. Now remember, there's lots of different ways we can write the derivative, because when it was discovered or invented or found upon, it was by two people, Gottfried Leibniz from Germany and Isaac Newton from England. So we have lots of different terminology. We can call a gradient function y dash. We can call it f dash of x. And the other more commonly used one is dy dx. So I'm going to use two of these. For the first one, I'm just going to call it f-x. That's finding the derivative of the function that we have. Remember, the function that we have is x squared plus 5x. We can call it the gradient function. Now remember what it is. It's f of x. Have a look back up here. F of x, the limit. Okay, well, we better write that. It's the limit as h approaches 0 of f of x plus h. Well, that's all this. That's f of x plus h. So, give myself a bit more room. X squared plus 2xh plus h squared plus 5x plus 5h. And I have to go minus f of x. Now I use a different color so you can see it. I have to go minus all of that. Now it's important when you do this, put it in parentheses so you don't mess up the sign. X squared plus 5x. And it's all over h. All right, now it's just a little bit of algebra. The limit as h approaches 0 of x squared plus 2xh plus h squared plus 5x plus 5h minus x squared minus 5x. When I brought those, I got rid of the parentheses. When I got rid of the parentheses here, they became minus x squared and minus 5x. Okay, let's go back now. What's going to happen? Well, let's get rid of that. The x squared minus x squared will cancel them out. And the 5x minus the 5x will cancel them out. And sorry, I've made a little boo-boo there. I'll get rid of that. That should be 5h. And there's that 5x. You can see it was 5h here, and I just didn't write it down there. So now, the limit as h approaches 0. Well, I've got 2xh plus h squared plus 5h over h. And I can now factorize on the top line. And I'll take the h out of everything, which gives me 2x plus h squared plus, just the one h, plus 5. And on the bottom, I've got h. The h will cancel, leaving me with this nice limit as h approaches 0 of 2x plus 5h plus 5. Now, as h approaches 0, that's going to become 0. So all I'm left with is 2x plus 5, which is the derivative or the gradient function, which is the equation or the function of the tangent. It's a tangent at any point on that curve, that original curve. All right, so that was 11b. Let's have a go at 11c. Let's first see what sort of, 11d. I'm pretty sure that's what I said I'd do. 5x squared minus x minus 1. Right, so I'm going to use a different terminology this time. I'm going to call it dy dx. I'm going to write my two functions. So f of x is 5x squared minus, wasn't it just x? Minus x minus 1. Minus x minus 1. Well, f of x plus h means I'm going to put this everywhere I have an x. I'm going to be careful with parentheses as well. So I've got a 5, I've got x plus h all squared minus x plus h minus a 1. We'll expand that. First I'll leave the 5. I'm going to do this squared bit here. So I'm just going to go, okay, well that's x squared plus 2xh plus h squared, which is why we did all that algebra in chapter 1. You've got to be very good at doing that. And then I'll just get rid of the parentheses here. So that's minus x minus h minus 1. Note how the h plus h became a minus h. Finally, we'll tidy it up. We get 5x squared plus 10xh plus 5h squared minus x minus h minus 1. And I can't make that any smaller because I can't collect any like terms because they're all different terms. Now let's go and do our differentiation. Remember, what we're finding is the limit as h approaches 0 of f of x plus h. So all of that minus f of x. So that, which I'm going to put in parentheses, and I'll use a different color. So here we go. 5x squared plus 10xh plus 5h squared minus x minus h minus 1. That's f of x plus h. Minus, now I'm going to go to blue, I'm going to write all this stuff here, I'm going to put in parentheses, 5x squared minus x minus 1. And all of that is over h. Okay, the limit as h approaches 0, 5x squared plus 10xh plus 5h squared minus x minus h minus 1. Now, I'm going to get rid of these parentheses, so it's minus 5x squared minus minus x plus x minus minus 1 plus 1 all over h. Now, watch what happens to all the things that don't have h in them. The 5x squared and the 5, and that should be a square there, sorry. They go. The minus x and the plus x goes. The minus 1 and the plus 1 goes. So now all I have on the top are things that have an h in them. I've got a 10xh plus a 5h squared minus h. They're the only things I've got left and on h. And again now I'm going to factor out h on top. I'm going to have h out the front. I'm going to be left with 10x. I'm going to have 5h minus 1 all over h. Now that h will cancel top and bottom, which means we're good because we can't divide by 0. And eventually I will have an expression without a fraction here. I'll have 10x plus 5h minus 1. Now as h approaches 0, this is going to go to 0. So the limit is what's left. And the limit, well, I don't even need to write that now. The limit will be what's left. And what's left is 10x minus 1. And that we can call the gradient function, the y dx, the derivative. So remember what we're doing. We are finding the gradient of the tangent, or the gradient function. How are we finding that? Well, we're finding two algebraic points on any curve. These 2 points. and we're subtracting the y values on top and we're subtracting the x values underneath. That will give us the gradient of the secant, but we do not want the gradient of the secant, we want the gradient of the tangent. Now, because we have one point that's a little bit more than the other, we want them to come together. So as that little bit, that h, gets smaller and smaller and smaller, the point comes closer and closer, or the 2 points come closer and closer together. And if we find the limit as that little bit approaches 0, we will get the gradient of the tangent. You need to be able to go and do this. Have a go at 11C. See how you go with that. And good luck.